and then we close the set. For some reason, a lot of textbooks will use this. I don't see a lot of, like when we go to the Fourier contest, they all use interval notation, the parentheses and the brackets. So I don't see a lot of you writing this out, but being able to read it is what's going to be important and know what it means. Okay. So we're going to practice some of these. Some of these are assigned. So the set of numbers x such that x is greater than 4 and x is an element of the natural numbers. So a math sentence translated into a verbal expression. So if x is greater than 4 and x is an element of the natural numbers, what's the first number in my set?
No, 5.
5. Am I including decimals in my set? No. Okay. The one advantage on set builder notation is you can restrict it to the natural numbers. Interval notation, you usually don't say x is just going to be natural numbers. So in this case, we can say all I want are the natural numbers greater than 4. So it'd be 5, 6, 7, 8, 9. We don't want any decimals, no fractions, any of that sort of stuff. Okay. So let's say we have this set. So this is just an example out of the book. They're just giving us 1, 2, 3, 4, ... How would you write that in set builder notation? So we're going to start, you can always start the same way. Start the bracket, x such that. And what is our set of numbers doing?
Numbers, what? What's increasing?
Increasing, starting at
1.
Okay. So we could say x is greater than or equal to 1. So you're just going to take what you see happening here. We're starting at 1. We're going up. It's going on forever. It's never stopping. And x is an element of what set? Natural numbers. If I put whole, would that be wrong?
Yep.
Not necessarily. If I put integers, would that be wrong? No, because you have this restriction right here. Now if I put rational numbers, because we do not want to include the decimals and fractions in between there. We just want the 1, 2, 3, 4.
Could you always just put real?
X is an element of the real, but if x is greater than or equal to 1 and you can choose any real number, then you could choose 1.1, 1.2, pi.
Yeah.
Okay, and those numbers are not in this set that we were given. So, okay. No, I don't want you to do that. You're just trying to run a system check. I don't think Stephanie and Juliana want to watch that. What if they give you like -5 is less than x, which is less than or equal to 2? They're going to give you an inequality. They say write that in set builder notation. These are actually pretty simple when they do it like this. Because that basically is your rule that you're going to put right in this spot. So choose a variable. In this case, we're going to use x such that this is our rule, such that -5 is less than x, which is less than or equal to 2. Now, the question you ask yourself is, can you include fractions and decimals? just saying x is between -5 and 2. So is it saying anything about excluding the fractions, decimals, irrationals, all that? No. So in this case, x would belong to the real numbers. Is that okay, Haley? The naturals. Okay. So this set, they're just saying all I want are the numbers 1, 2, 3, 4, 5, 6, 7, 8. That's all they want. They don't want fractions. They don't want the decimals. This one is just saying x can be anything between these two numbers. Okay. Okay, this one's a little bit different. If they say something like multiples of 5, how you write that? And then we'll move on. So if you want multiples of 5, start the same way, x such that x equals 5n. We're going to just throw another variable in there, of course. If you're a multiple of 5, that means you've been multiplied by 5. So your multiples of 5 are 5, 10, 15, 20, 25, 30, -20, -25. Okay. So if you're a multiple of 5, that means you can be divided by 5. So that if you can be divided by 5, that means you've also been multiplied by 5. So our restrictions are going to go off the value n now. So n has to belong to the integers. Okay, so the restrictions will go off the value of n. So x equals 5 times something. But n has to be an integer, n has to be the number line number. So if I say n is 4, what's 5 times 4? 20. Is 20 a multiple of 5? If I go 20, what's 5 times 20? Is 100 a multiple of 5? Okay, so that's how you deal with things that are multiples of 5, or multiples of anything. So if this was multiples of pi, it'd be x equal pi n. So whatever it's a multiple of, that's the number that goes right there. Alrighty. Doing okay? Stand up. Wake up. Watch the rain. Oh, get dark. You sore? Tired? Stiff on Saturday? Good. Long day? Yeah. The interval notation, do you want to review that? I mean, we can just practice these three down here. If you want to write those in interval notation, we'll see if we got it or not, or you can try it and I explain it, or I can show you what the answers are. Okay. So on this one, -4 is less than or equal to y, which is less than -1. So y can equal -4, but it cannot equal -1.
So, what if you have bracket?
Am I going to show you, or are you going to tell me? Okay. So this one would be a bracket. We make sure it's the lower bound, comma, upper bound. It has to be lower bound, comma, upper bound. Never put a positive infinity on the left-hand side. So this is interval notation. Okay. So it has to be lower bound, upper bound. The bracket represents when you can equal a value. So since y can equal -4, we're going to use a bracket. Parenthesis is when you can approach a value, but you cannot equal it. So since y is less than -1, you can get approach -1, you get closer, 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 closer to it. But then you can't actually get there. What's the closest number to -1? That is -1. Maybe this is your other question. Does 0.9 repeating equal 1?
Yeah. I think.
What? So
Depends how many 9s you put. Just kidding.
So it's repeating, goes on forever. 0.9. Maybe I should write this down. Stephanie, Juliana, know what I'm talking about? Does 0.9 repeating equal 1? So kind of the rule is 2 numbers are distinct. 2 numbers are separate if there's a number between them. So a number 1 is different than number 2 because there's numbers between them. We know that they're separate numbers. Okay, 1.1 is different than 1.2 because we know there's separate numbers between them. So is there a number between 0.9 repeating and 1? So they must be the same number, right? This is a little bit of, you get high enough in math, and you're not there yet. Math becomes philosophy, theories, ideas. Okay? Trying to prove crazy stuff like that. Okay, let's do, anyway, back to real world. A is greater than or equal to -3. So interval notation, writing that in interval notation. So A is greater than. If you need help, think mentally. Get it in your head. Get the number line. -3, if you're greater than -3, what direction are you going? Right or left? Right. So in your head, you're visualizing it. You're seeing it. -3 going to the right. What's my lower bound? What's my left side? What's my left bound? -3. Can I equal -3?
Yeah.
So it's a bracket. Going forever to the right. So to infinity. Can I equal infinity? No, infinity is not a number. If there's a number, then you could count to it. What's that? Oh, you can put positive infinity. That's okay. If it's not written in there, it's assumed to be positive. I know last time I did stress putting a plus and a minus in there. But, okay. So this is kind of a common one to put the infinity on the left side because the -3 is written on the right side. So visualize, write out a number line if you need to. Okay. X is greater than 9, or X is less than -2. How do we do a disjunction? This is a disjunction because it has an or statement. So what symbol did we have to use with the disjunction in between the two sets? Okay. I know if you take college algebra through ITV next year here, you will be using set notation. Okay. Some of the kids needed a little refresh.